Something strange is happening in our skies. An object known as 3I Atlas has entered our solar system, and it's defying everything we thought we knew about interstellar visitors. It glows when it shouldn't, it moves when it shouldn't, and the deeper astronomers look, the more impossible it becomes to explain. First, it turned bright green, yet the chemistry behind that color simply doesn't exist in any known comet. Then, it began releasing metals and gases at distances far too cold for such reactions to occur. And now, after months of observation, its trajectory is holding steady, unnaturally steady, as if something or someone is controlling it. Astronomers are baffled. Telescopes across the planet are tracking its every move. And hidden within the latest images of 3I Atlas lies a mystery that could change everything we believe about life, technology, and the origins of intelligence in our galaxy. This isn't just another comet, it's something else. And whatever it is, it's heading our way. When astronomers first spotted 3I Atlas, they thought it would behave like any other interstellar comet, a frozen remnant of some ancient system, passing quietly through our own before disappearing forever. But from the very beginning, nothing about it has been normal. It was discovered earlier this year, and almost immediately, astrophotographers across the world began noticing something impossible. In the deserts of Namibia, during a rare lunar eclipse that left the sky in complete darkness, telescopes caught a strange green glow radiating from the object. Under natural conditions, a comet shouldn't look like that, and especially not this one. Here's why. Normally, that vibrant green color comes from a molecule known as diatomic carbon, or C2. When ultraviolet radiation from the sun hits these carbon molecules, they emit a distinct green light, a chemical signature so well understood that it's used to identify comets even from millions of kilometers away. But 3I Atlas doesn't have those molecules. Every spectral reading we've taken shows it's deficient in diatomic carbon. By all known chemistry, it should be completely incapable of glowing green, and yet there it was, shining like a neon beacon against the darkness of space. If it were just the color, scientists might have dismissed it as an optical illusion or a quirk of observation. But the deeper we looked, the stranger it became. The coma, that luminous cloud of gas and dust surrounding the object, isn't behaving like any other we've seen. It's dominated not by water vapor, as expected, but by carbon dioxide, and in extreme proportions, nearly 16 times more CO2 than H2O. That alone is wildly abnormal. It suggests the object formed in an environment utterly unlike any region of our solar system. But that's not the only anomaly. Spectroscopic readings also detected nickel metal dispersed throughout its atmosphere, at a distance where temperatures are far too cold to vaporize metal of any kind. Under normal conditions, that kind of metal emission only happens when a comet passes dangerously close to the sun. But when the nickel was first detected, 3I Atlas was still between Mars and Jupiter, bathed in cold cosmic light. Nothing in standard physics explains that. Theories have ranged from unusual internal heating to unknown chemical reactions deep within the nucleus. And yet, none fit the data. The only processes we know of that could release nickel gas under those temperatures are artificial. Rocket engines, for example, often expel exhaust rich in nickel and carbon dioxide. But suggesting such a thing opens doors scientists aren't ready to walk through. Still, one fact remains. 3I Atlas isn't behaving like a comet. Its chemistry defies explanation. Its glow breaks the laws of known physics. And its stability, as we'll soon see, is unlike anything natural we've ever tracked. Because what 3I Atlas is doing next shouldn't even be possible. By now, the chemistry of 3I Atlas was already challenging everything we thought we knew about comets. But when astronomers began tracking its motion, they found something even stranger. From the moment it was first observed, 3I Atlas has been following a near-perfect trajectory, steady, precise, and unwavering. No tumbling, no chaotic deviations, just a clean, almost mechanical path through space. At first, that might not sound unusual, but for an object that's supposed to be a comet, a loose cluster of ice, dust, and volatile material, it's practically impossible. You see, when a comet approaches the sun, its frozen surface begins to heat up and release gas. That process, known as sublimation, acts like a natural thruster, pushing the comet in unpredictable directions. These small variations in velocity are so common that scientists have a name for them: non-gravitational accelerations, or NGA. They're what make comets drift, spin, and shift as they move closer to the sun. But 3I Atlas isn't drifting. It isn't spinning wildly or losing mass in a way that changes its course. Across months of observation, from its discovery in May to its latest tracking data in October, its trajectory has remained almost perfectly stable. It hasn't sped up, slowed down, or altered direction by any measurable amount. Statistically, that's unheard of. Most comets fluctuate by several kilometers per day due to gas jets and surface activity. Even interstellar visitors like Oumuamua and 2I Borisov behaved according to that pattern, and both displayed significant non-gravitational acceleration as they heated up. Let's look at the numbers. For 3I Atlas, its average change in velocity has been measured at around 1.5 kilometers of NGA per day. Compare that to Borisov, which fluctuated by over 100 kilometers per day, and Oumuamua, which changed direction by as much as 1,000 kilometers per day. Even the massive comet Hale-Bopp, one of the largest ever discovered, showed over 10 kilometers of variation per day. 3I Atlas, in contrast, has remained eerily consistent, almost as if something is maintaining its course. Now, one explanation could be that it's simply too massive to be easily moved by solar heating. That's a reasonable idea, until you consider that Hale-Bopp was even larger, yet still showed normal, measurable drift. So size alone doesn't explain what's happening here. Another theory suggests that its outer layer might be unusually stable, perhaps coated in some material that prevents rapid outgassing. But even then, no known composition could hold such a steady trajectory for this long while still showing active sublimation and tail formation. In other words, it's active, but unmoving. To many scientists, that's the most baffling part. It's behaving like a comet in every visible way, glowing, venting, releasing gases, and yet it moves through the solar system like a guided probe. Some astronomers have compared its motion to that of a spacecraft under continuous course correction, as if some invisible guidance system were keeping it perfectly aligned as it passes through our inner solar system. Of course, that sounds absurd, until you realize that we've seen similar mysteries before. Oumuamua's acceleration, for instance, couldn't be explained by outgassing either, leading Harvard astrophysicist Avi Loeb to famously suggest that it might be artificial, a fragment of alien technology propelled by radiation pressure. That idea was ridiculed at first, but as each new interstellar visitor arrives, the line between natural and engineered grows thinner, and so, as 3I Atlas continues on its strangely precise path, scientists are left with two equally unsettling possibilities. Either it's the most stable natural object ever recorded in interstellar space, or it isn't natural at all. Whatever the truth is, one thing is certain: It's not behaving like anything we've ever seen. And if it can hold a perfect course, could it also change course whenever it wants? Because if that happens, it means something out there isn't just visiting our solar system, it's watching. For decades, astronomers have searched the sky for any sign that we're not alone, but few signals have ever sparked as much curiosity or fear as one that arrived in 1977. It came from deep space, a narrowband radio transmission so powerful, so distinct, that the astronomer monitoring the data simply wrote one word in the margin of his printout: wow. For 72 seconds, a beam of energy hit the detectors of the Big Ear Radio Telescope in Ohio. It wasn't random noise, it wasn't a glitch, and it wasn't coming from Earth. Its frequency was measured at 1420 megahertz, the exact frequency of the hydrogen line, the most abundant element in the universe. That detail has haunted scientists for decades, because if any intelligent civilization wanted to announce itself to others across the stars, that's the frequency it would use. A universal cosmic calling card, recognizable to anyone who understands basic physics. The signal never repeated. No other telescope has ever detected anything like it. And eventually, the wow signal faded into mystery, unexplained, unconfirmed, and unforgettable. But here's where things get even stranger. Recent trajectory modeling shows that 3I Atlas, this interstellar visitor, now cutting across our solar system, appears to have originated from the same region of space the wow signal came from, the constellation Sagittarius. A coincidence? Possibly, but the alignment is eerie. If 3I Atlas truly began its journey from that same direction, then when the wow signal reached Earth in 1977, the object could have already been entering the outer edge of our solar system, as if the transmission was a message announcing its arrival. That's speculation, of course, but the math fits. And the timing, the direction, and the energy profile all paint a chilling possibility that the wow signal wasn't a random burst from a distant star, but the first whisper from 3I Atlas itself. If that's true, then we've been hearing from this object for almost 50 years, and maybe, just maybe, it's been listening too. The deeper astronomers looked at 3I Atlas, the stranger it became. Spectral data revealed chemistry that shouldn't exist. Its motion defied physics. But when telescopes finally captured high-resolution images of the object, everything scientists thought they knew unraveled in an instant. At first glance, the early frames looked ordinary, a faint, glowing blur drifting through the stars, just another icy body reflecting sunlight. But when the James Webb Space Telescope and Hubble combined their imaging data with several powerful ground-based observatories, the results were unlike anything seen before. Hidden within the fuzzy halo of the comet's tail were patterns, geometric, symmetrical, too precise to be natural. What appeared as random streaks of gas and dust began to form repeating, angular shapes, straight lines intersecting at perfect right angles, grids that stretched like scaffolding across the coma. At first, analysts dismissed it as a digital artifact, a trick of overlapping exposures or sensor interference. But when three independent instruments, operating at different wavelengths, confirmed the same grid-like formations, the whispers began. This wasn't an optical illusion, it looked constructed. Even more unsettling was the behavior of its tail. Comet tails are supposed to flow away from the sun, shaped by the pressure of solar wind. But the tail of 3I Atlas didn't follow that rule. Instead, it twisted back on itself, curving in rigid arcs, almost mechanical, as if guided by some unseen framework or magnetic structure. When scientists modeled the motion frame by frame, the result didn't match any known form of outgassing or dust ejection. It looked controlled, Inside NASA and ESA, analysts quietly compared the tail's pattern to the exhaust plumes of ion drives and plasma thrusters, technologies that produce similar structured flows. Officially, the agencies made no comment. Unofficially, the idea that 3I Atlas could be artificial was no longer being laughed out of the room. Then came the core images. When infrared data from James Webb was processed, astronomers expected to find a dense nucleus at the center of the coma, a solid core of rock and ice, as every comet possesses. But the data showed something impossible. There was no core. Instead of a solid body, Webb detected an empty region, a pocket of complete darkness that absorbed all wavelengths, a void inside the object itself. And yet, that void wasn't silent. It pulsed. Every 11.2 seconds, a faint flash of infrared light flickered from the heart of the darkness. A perfect rhythm, not random, not natural. Some researchers described it as a heartbeat. Others compared it to a signal. Natural phenomena rarely pulse with such precision. Even neutron stars and pulsars, known for rhythmic emissions, vary subtly over time. This pulse did not. It was consistent down to the millisecond. When analysts overlaid the timing of those pulses with light distortions in the surrounding star field, they discovered something even more disturbing. Each pulse corresponded with a warp in space-time itself, a faint spiral distortion in the starlight behind it, like gravity twisting the very fabric of reality. That shouldn't happen. 3I Atlas doesn't have the mass to bend light that way, and yet it was doing it, repeatedly, predictably, as though it were manipulating light, not merely bending it. To explain the data, some theorists proposed that the core of 3I Atlas might contain a compressed region of space-time, a kind of cavity where geometry folds in on itself. A theoretical transit chamber capable of moving through the universe not by traveling faster than light, but by shortening distance itself. It sounded like science fiction, but the models fit disturbingly well. If true, then 3I Atlas wasn't a comet at all. It was a vessel, a machine built to cross the gulf between stars using a technology we can't even begin to replicate. And while this theory remains unproven, the implications are staggering. If the images are genuine, if those pulses, grids, and distortions are not errors, then humanity may have just photographed the first engineered object from another civilization. For now, NASA remains silent. The official explanation speaks of data calibration and optical interference. But behind closed doors, multiple agencies are reviewing the raw data, because if even one frame of those images is authentic, it changes everything we know about life, technology, and the boundaries of physics. And perhaps the most haunting question isn't what 3I Atlas is, but why it's here. For now, 3I Atlas continues its silent journey through the solar system. Astronomers track it night after night, logging every flicker, every emission, every anomaly. But for all the data we've gathered, one thing is clear: the more we learn, the less we understand. By all accounts, 3I Atlas should be a comet, a frozen remnant of another star system, drifting aimlessly through interstellar space. And yet, every observation points towards something more deliberate. Its green glow without carbon, its metallic vapor without heat, its tail that bends against the solar wind, its motion so steady it could pass for navigation, and its pulse, the rhythm echoing deep within the void of its core. Science thrives on patterns, but when those patterns start resembling intention, the lines between natural and artificial begin to blur. Officially, NASA calls it a highly unusual interstellar object. Unofficially, even within the agency, the tone has shifted. The question is no longer what it's made of, but who made it, or if anyone did at all. Perhaps it truly is natural, a relic from a dying solar system carrying the strange chemistry of its home star. Maybe it's a cosmic coincidence that its path mirrors intelligence. Maybe the pulse is an internal resonance, a chemical reaction repeating like the ticking of an ancient clock. But if even a fraction of the evidence holds, then this may be the first artifact from another civilization, a vessel so ancient, so eroded by time and radiation that all that remains is its framework, still functioning on instinct, still following a course set eons ago. And maybe, just maybe, we're not its first audience. Because if 3I Atlas is more than a comet, then it has crossed unimaginable distances to reach us, traveling not for years, but for millennia. And what if it has passed by other stars before ours, worlds that also wondered who built it, civilizations that also pointed telescopes upward and saw the same flickering light, a ghost crossing the dark between suns? That idea alone changes everything. It means that across the galaxy, others might be watching the same traveler, each wondering if they were the first or the last. The truth for now remains hidden in its silence. No transmission, no signal, only motion, deliberate, unwavering, and ancient. Maybe it's waiting, maybe it's observing, or maybe it's simply passing through, a messenger whose creators vanished long before our sun was born, until it turns, slows down, or vanishes beyond the glare of the sun. We may never know what 3I Atlas really is. But one thing is certain, this object is rewriting the story of what it means to be alone in the universe. If you followed this far, if you've stared at the data, the images, and the impossible coincidences, then you already feel it too. Something about this doesn't add up. So stay curious, because in the weeks ahead, 3I Atlas will reach its closest point to the sun, and whatever happens then, eruption, silence, or revelation, it will change how we see our place among the stars. And if you want to be here when that happens, subscribe, turn on the bell, and join me for the next chapter, because this story, the story of 3I Atlas, is only just beginning.